on your test, there's going to be a couple of pathway problems. There's going to be one regular pathway problem, very much like B or F, where there are several different rectangles, but they have no overlap. They only touch at the very, very tippy-tip corner. And so you could use permutations to say how many rights, how many downs. That's one rectangle. How many rights, how many downs, how many rights, how many downs, and then multiply your three rectangles together. Pascal's will also work, by the way. And then there will be one, probably on the written section, irregular pathway question. Much like, oh, G or H or I or J or K or C. No 3D ones, although they're nerdily cool. I'll start out. Any questions you want me to go over? Ellen? Can I do J and K? Yes. Okay. I'm going to be clever in J. I'm going to go from B to A because it's easier for me mentally to work my way downwards. And I would have rotated my book 45 degrees so that B was here and A was here so that I can really work downwards, yes? And I would say, haha, 1. Then I would say, haha, zoom in. Talk to me, Ellen. Yes? Yes. Yes? Yes? Yes. Yes. Yep. 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 And a dead end, apparently. There's 10 ways to get there, but you can't get out of there. Oh, okay. Because you can't go up or right. Or, in this case, in the direction that I'm going, right? You always got to be going closer to your destination. Keep going. Yep. Yep. I think 6, yes. 5 plus what? 5 plus nothing. 5. 10 plus what? 10 plus nothing. 10, right? Keep going. I think we got through the hard stuff. 11, 15, 25, 36, 40. Is the answer 76? 66? Because this isn't 40. This is, what have I added wrong? Sorry, say to what? 26. It's not 36, Mr. Dueck. Check your math, Mr. Dueck. Spencer. No copy. You should try this. Anyways, that's how I do that one. Okay. Speaking of K, this what the? Hey, start here because that looks nicer. Yes? I'm going to start there. Okay, here we go. Talk to me, Ellen. Yep. 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 1. Okay, now I'm going to be a little careful. 1. Definitely a 3. I guess only a 1 there because this 2 is not connected. 1. 1. 4. 4. 2. 1. Okay. 5, 8, 6, 3, 1, 13, 14, 9, 4 and a dead end. 27, 14 and 9, 23. I could fill this in, but it looks like what I think A is just is A23, it seems like. And I'm quitting because I got to my destination. I've never successfully done that, this one going from A towards B. So if you're wondering, how do I go in the correct direction? I never bothered trying to figure it out, Brett, because I had an easier direction and knew I'd get the same answer. So for those 8 of you sprawling like mad, you can practice this yourself. Okay. I would consider K a little over the top. I think you can expect stuff like G or H. Actually, J is a good example. The odds are pretty good. What I'll do is I'll create a table, which will be rectangular. And then using Word in the table, I'll turn off certain cells and make them invisible, which basically means it'll look kind of like this with various gaps along the way. That's the easiest one for me to make up with graphics, which shouldn't be how I evaluate you. It shouldn't be my criteria, but sometimes my criteria for how I evaluate you is how tough is it to create this question in 5 minutes. If it's too tough, I ain't asking it. It's terrible, I know, Trevor. So what? There's the real life. Any others? Okay, pathway problems. Kind of a neat application of Pascal's triangle. But as it turns out, not necessarily the nerdily neatest. Today, if you would be so kind as to get out your handy-dandy notes to Lesson 6, probably the most impressive sounding thing you'll learn all year, the binomial expansion theorem. Kara, what did you learn today in school? Mummy, I learned the binomial expansion theorem. Oh, Kara, you are learning such things. We are ever so proud of you. I'm going to try and get through this in a day. I might not. I also have a take-home quiz for you. Then I have one great big unit review take-home quiz, which used to be my test. And then your test. Eric, can you read to me this word right here? Nice and loud. Two-term, you know what? A two-term thingy in a bracket. Expansion, you guys called that FOIL. What we're going to ask ourselves today, Eric, is this. Don't write this down. You can probably, most of you, do that in your head. What if I said, I'd like to do that? Up until now, the only way you had to do that was to write out 6 of those, multiply the last 2 together, get an answer, then multiply the third one in, gather like terms, get an answer, then multiply the fourth one in, gather like terms, get an answer, then multiply the fifth one in, gather like terms, get an answer, then multiply the 6th one in, gather like terms, hope to heck that you haven't made a mistake. And that was your answer. As if we keep it that way. There's got to be a better way. What we're going to do is we're going to look for a pattern. It says, expand and simplify each of the following powers of the binomial a plus b. So a plus b squared, that means a plus b times a plus b. Remember your little FOIL acronym? You get this. A squared plus ab plus b squared. Except, you know what? I'm going to move this over a bit. I have a good reason for this. I'm going to write it kind of centered. A squared plus ab plus b squared. If you didn't, that's okay. This is going to make a pattern easier to spot. Yes? Plus 2ab. Good gosh. Thank you, Ellen. Candy for you later. A plus b all cubed. Now what this means is a plus b, a plus b, a plus b. If I was doing this without a shortcut, what I would do is I would say it's a plus b times a squared plus 2ab plus b squared. It's those two multiplied, which I know is that, Maria, times this guy in front. However, I'm just going to tell you what the answer is. Turns out it's a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the fourth means a plus b times a plus b times a plus b times a plus. It's really a plus b times this thing. I'm actually just going to tell you that it's a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Mr. Dueck, you're so smart! How are you doing this in your head? First of all, does anyone notice a pattern with the a exponents? Run your eyes down along the terms, and what do you notice as the pattern with the powers of a? Dominique? Not the same exponent. That's a 4, that's a 3, that's a 2, that's a 1. What's the pattern? You know what? It goes down by 1. In fact, it's 4, 3, 2, 1. Technically what? 0, because a to the 0 would be an invisible 1. what do you notice about the exponents of the powers of b? It's the opposite. None, 1, 2, 3, 4. Yes? Oh, and what do you notice when you add those two exponents together, Brett? What do you get? What do you get? What do you get? What do you get? Okay. So, not increase, Mr. Dueck. That gives us a shortcut, Tyler, to at least find the powers, the variables. I'll show you what I mean. I'm pretty sure a plus b to the fifth is going to have an a to the fifth, a to the fourth, a cubed, a squared, a nothing. And Ryan, I'm pretty sure that a plus b to the fifth is going to have a b to the nothing, b to the 1, 2, 3, 4, 5. That's pretty good. What I haven't done is yet figure out what number. Well, it's positive, so I know everything is going to have a plus sign in front of it. Okay. But I haven't figured out a pattern for the coefficients, and now I pause and I say, does anybody notice the coefficient pattern? Sabina. What? Say that louder, please. It's Pascal's triangle? Hang on, let me see. Pascal's triangle had a 1, 2, 1, and then it was 1. 1 plus 2 is 3, 2 plus 1 is 3, 1. And then it was, oh, there was a 1 down here, and a 1 plus 3 is 4, and a 3 plus 3 is 6, and a 3 plus 1 is, oh, no way. Really? No. Okay. 1. Right? 1 plus 4 is 4 plus 10 is, sorry, 4 plus 6 is, 4 plus 6 is 6, 4 plus 1 is, and then, oh, 1. But you know what? There's a better way to remember this, because right now, Ellen, I had to look at the previous row of Pascal's triangle to figure this out. What if I didn't have the previous row? We had another way to find terms in Pascal's triangle. We said it was chooses. Pardon me? Yeah, oh yeah, we got that a while ago, Eric. Sorry? 4 plus 1 is 5? Oh, you're saying I did this wrong? Eric, thank you. Believe it or not, you get a candy. And believe it or not, you were paying attention. Holy smokes, Eric! I'd almost say show up late more often, but it annoys me so much. Eric, my friend, what's the exponent right here? What's the second number? That term right there is a 5. Do you remember? This actually told us the chooses. This is actually 5 choose 0, a to the 5th, plus 5 choose 1, a to the 4th, b, plus 5 choose 2, a cubed, b squared, plus 5 choose 3, write this down, a squared, b cubed, plus 5 choose 4, a, b to the 4th, plus 5 choose 5, b to the 5th. Why is that a nicer way to remember this? Because, Dominique, all I have to do is look at the exponent, and the exponent tells me what my chooses are. There's my coefficients. And then the powers go from my exponent down by 1 for the first term, and from 0 up by 1 until I reach my exponent for the second term. That's not bad. In fact, Joel, I would almost argue that I can memorize that. You'll have to. But we'll do it enough that you'll just get the hang of it. Okay. So, next page, it says, visualizing the binomial expansion of a plus b to the 4th. And it says this, example 1, expand x plus 1 to the 4th power. Okay. A plus b to the 4th is going to be 4 choose 0, a to the 4th, b to the 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. In fact, Brianna, when I do these, I generally write out the chooses first, leaving spaces in between. Then I write out the powers of a going down by 1. Then I write out the powers of b going up by 1, because that way I can do it nice and systematically. Okay? In other words, this here is going to be, what's my exponent, Dominique? 4 choose 0, leave a space, 4 choose 1, leave a space, 4 choose 2, leave a space, 4 choose 3, leave a space, 4 choose 4. And then it's going to be a to the 4th, a cubed, a squared, a to the 1, no a. And then it's going to be, oh, no b, whoop, b to the 1, b squared, b cubed, b to the 4th, and now I'll put plus signs in between everything so that it's fairly separated. Carly, that's my generic template, except what's sitting where the a is in my original question? Let's put a little a right above there. What's sitting where the b is in my original question? I gotta be fussy, not just a 1, a positive 1. Let's put a little b right there. And now let's substitute everything in. Here we go. Equals. There's a reason I told you to memorize anything choose 0, because I knew this lesson was coming too. What's 4 choose 0? Really? Huh? A to the 4th is going to be x to the 4th. Yes? Plus, I also did tell you it was worth memorizing what 4 choose 1 is, what anything choose 1 was. Anything choose 1 was just itself. 4 choose 1 is just plain old, because it's lots of typing otherwise. 4 x cubed times 1, which isn't going to make a difference, but if there was another number there, that would make a difference later on. Plus 4 choose 2, I don't know. 6. And it's going to be x squared, 1 squared. By the way, what if, instead of having a 1 right here, Kara, what if we had had a, look up for a second, what if we'd had a 2 right there? There would be a 2 right there. What would 2 squared be? Times the 6 in front, I'd have a 24 in front of everything on my next line. That would be my coefficient. Let's keep going. Plus, what's 4 choose 3? Oh, wait a minute. Isn't that the same as 4 choose 1? Because we said you can't form groups of 3 without forming groups of 1. Oh, heck, let's just, instead of retyping it, reuse that number. 4 choose 1 is 4 x 1 cubed. Plus, what's 4 choose 4? 1. And then b to the 4th is 1 to the 4th. Now let's tidy all this up. You can cross out b. We're not going to fit it in. We're going to just move straight down and do c in a second. So where b is right here, we can write our final answer. How would I write 1x to the 4th? Just plain old x to the 4th. Plus, how would I write 4 times x cubed times 1? What's a tidier way to write that? Just 4x cubed. Plus, how would I write 6 times x squared times 1 squared? Plus, how would I write 4 times 1 cubed? Sorry, 4 times x times 1 cubed. 4x, right? Plus, how would I write 1 times 1 to the 4th? There's the final simplified version of that. C, except instead of a 1, can you go plus 4, 2x plus 4 all to the 4th. Okay. Trevor, what's my exponent? So it's going to be 4, you know what? It's going to be, here we go, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Don't forget to start with a choose 0, by the way, Ryan. That's the common mistake. Trev? That's sitting where the A is. That's sitting where the B is, yes? So it's going to be a to the 4th, a cubed, a squared, a none. No b's. 1b plus b squared plus b cubed plus b to the 4th. There's our template. There's our pattern. Now it's just a matter, Emily, of very careful substitution. Here we go. Four choose 0. Oh, that was 1. What's sitting where the A is? 2x all to the 4th. Plus. 4 choose 1. We said that was 4. What's sitting where the A is? 2x in brackets all to the 3rd. What's sitting where the B is? A 4 to the 1. And this is one of the few times where I do put 1s as exponents because it helps me keep track of my, hey, do they all add to the 4? Plus 4 choose 2. Well, that was that 6? That was 6? A squared, 2x all squared, 4 all squared. Plus 4 choose 3. 4 choose 3. Oh, that was 4, wasn't it? Because it was the same as 4 choose 1. 4. A is 2x to the 1. It's a terrible looking bracket, Mr. Dueck. It looks like a 1. 4 to the 3rd. Plus 4 choose 4. 1. 4 to the 4th. Okay, let's get our calculators out, unless you're really, really good at exponents and multiplying. Let's tidy this up. Numbers first, then variables in the first term. So in the first term, I have 1 times 2 to the 4th. See it? 16. And what about my variables? X to the what? I think the first term simplifies to, cross out D by the way, 16 x to the 4th. And then a plus sign drops down. Second term. Tyler, can you see? It looks like I have a 4 times a 2 to the 3rd. See it, see it, see it, see it, see it? Times a 4 to the 1, which I'm not going to bother typing. See it all there, Ryan? The coefficient is going to be 128. What about my variables? X to the what? X cubed. Plus. The next term, it looks like I'm going to have a 6, a 2 squared, and a 4 squared. For my coefficient. 384. Spencer, what are my variables going to be? X to the what? Yep. Plus. Looks like in the next term I'm going to have, with my calculator, I'm going to have a 4 times a 2 to the 1 times a 4 to the 3rd. 512? And then it's going to be an x to the 1. Okay, I won't bother writing the 1 in my final answer. Am I wrong, Brett? Oh, okay. Plus, and Brett, what am I going to have on my last term? 4 to the 4th. 56. This is the binomial expansion theorem. Not too bad. Way shorter than doing it the long way. E. First of all, cross out F, because we're going to use lots of room. And instead of x plus 1 to the 5th, cross this out, and here we're going to put next to it 3x minus 2y all to the 5th. Oh, by the way, some built-in error checks. Emily, what was the exponent in this example right here? How many terms count? What's the exponent here, Spencer? How many terms count? What's the exponent here? Maria? How many terms count? How many terms? 6. Yes? Gonna be 6. In other words, now you know if you've missed one. What's the exponent, Kara? 5 choose 0, 5 choose 1, 5 choose... Write that out, leaving spaces in between, all the way up to 5 choose 5. Don't forget to start with 5 choose 0. Kara, what's my exponent? A to the 5th, A to the 4th, cubed, squared, 1, none. Kara, what's my exponent? None, b to the 1, b squared, b cubed, b to the 4th, b to the 5th, and now I'll put plus signs in between everything. Although some of these terms later on might end up being negative when I start taking care of all that. Is it okay, Ryan? Right? That's the pattern. That's what you'll need to know in terms of memorization. But do you see how I've tried to show with Kara here how you can kind of almost, not derive it, but it almost kind of falls out. You keep asking, what's the exponent? And you go with the pattern, right? Okay. Oh, except I got to be a little careful. That's A, 3x. And what's B? Careful, don't say 2y. What's B? Negative 2y. Okay. Tyler, it's the kids that take shortcuts on this that lose the marks on this. Don't take shortcuts on this. Here we go. 5 choose 0. That I can do right now. Oh, I don't need to go to my calculator. What is 5 choose 0? 1. And then it's going to be 3x all to the 5th. Plus. And I don't really need to go to my calculator for 5 choose 1, hopefully. Justin, what is 5 choose 1? 5. There's a reason I worked this in earlier, by the way. It's because of this lesson. 5, and then there's going to be a 3x to the 4th, and then a negative 2y to the 1. By the way, can you see, I think this term eventually will end up being negative. There's going to be a minus sign in front of it. Plus, I don't know 5 choose 2. What is 5 choose 2? Sorry? 10? And then it's going to be very, very carefully 3x to the 3rd, negative 2y squared. Oh, by the way, can you see this term is actually going to end up being positive, because where's that negative sitting? Inside a squared. If I was doing a multiple choice question right now, I would probably say to myself, you know what? It's going to go positive, negative, positive, negative, positive, negative, and I would cross out any answer that was all positive or all negative. Yes? Because I'm a good test writer? Yes? Let's keep going, Vlad. Don't type in 5 choose 3. If 5 choose 2 is 10, what's 5 choose 3? Also 10, because you can't form groups of 2 without forming groups of 3. And then 3x all squared negative 2y all cubed plus. And Alex, don't type in 5 choose 4, because if I know what 5 choose 1 is, I know what 5 choose 4 is. What? Woohoo! Shortcuts. A 3x and a negative 2y, running out of room, Mr. Dueck, to the fourth. By the way, this term is going to be positive, I think. This term will be negative because the negative won't cancel when I do my exponents easies. Plus, Caitlin, what's 5 choose 5? 1. I'll write that, I guess. And then it's going to be negative 2y, running out of room, to the fifth. Question? Good? Okay, now we get our calculators out. And I like to do all of the numbers first to get the coefficient SR, and then I do all the variables, because usually the variables, I can just do the exponents in my head. What's x to the fourth? X to the fourth, right? What's y to the third? It's just y to the third. But, in this first term, can you see SR? I have 1 times 3 to the fifth. Did I need to type the 1 times? Probably not, Maria. I did just so I didn't lose you guys, right? 243? Yes? $243, and then, Maria, I think the x to the fifth would just drop down like a domino. Yes, 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 yes? Plus. Okay, in the second term, I have a 5 times 3 to the fourth times, now I have to give you a caution. Whenever you're dealing with negative numbers and exponents, your calculator requires you to put the negative number in brackets with the exponent on the outside. Now I realize, Sabina, the 1 this time doesn't make a difference, but I'm going to see if I can go second function enter and kind of use this as a template, because I think the 3 exponent's going to be going down by 1 and the 2 exponent's going to be going up by 1, and I'm lazy. But if you are going to type in a negative number with an exponent, you've got to put the negative in brackets with the exponent on the outside of the brackets. Anyways, you get negative 810. You know what? I shouldn't have written that plus sign. That was silly of me. Minus 810. X to the what? Y to the what? X to the fourth, Y to the 1, which I'm not going to bother writing now. I won't write a plus sign down this time. I'll make sure I'll find out whether it's positive or negative. Although I think this one is positive, but let's find out. So this is going to be 10 times 3 to the third times bracket, negative 2 close bracket squared. Syntax. What did I type wrong? The third didn't show up, Mr. Dueck. 3 to the third times negative 2 squared. Positive 1080. Yes? X to the what? Y to the what? Brett, sorry? X cubed y squared, is that what you're saying? Yes. X3 battleship, Y3 battleship, X to the 3 or X squared. Did you say 2 to the first time, or did you say, I thought I heard you say X3. Maybe you didn't. Next one, I think is going to be negative, but I'll hold off. It's going to be 10 times that, okay. Now, yeah. Justin's going to raise a point. He's going to say, hey, Dueck, if I'm okay at exponents, can I do some of these in my head? I'll be honest. This is what I would type for this third one. 10 times 9 times negative 8. Because I know that 3 squared is 9, and I know that negative 2 cubed is negative 8. Yeah, go ahead. It's negative 720. Justin, X to the what, Y to the what? 5 times 3 times, I think 16, but if you're not sure, 5 times 3 times negative 2 to the 4th. 240 positive plus xy to the 4th. 1, 2, 3, 4, 5. How many terms did I say the final answer was going to have? We should be on our last term. It's off my page. Negative 2 to the 5th minus 32 y to the 5th. The binomial expansion theorem, another application of Pascal's triangle. A very, very nice shortcut application. On your test, Carly, what will I do? I'll tell you exactly what I'll do. On the written section, you'll get something like this, but it'll be maybe to the 8th or to the 9th power. Now I don't, and I'll say write out the first 4 terms and quit. In fact, the reason it's going to be 4 terms is I'll probably go, if it's a 4 marker, 1 mark per term, or if it's a 2 marker, half mark per term. So if I just say write out the first 4 terms, Tyler, just write out the first 4 terms. So if it was a 9, it would be 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3, theta to the 9th, theta to the 8th, theta to the 7th, theta to the 6th, no b, b to the 1, b to the 2, b squared. I figure if you can get the first 4, you can get the rest. Otherwise, these questions take too long. Although they're still way shorter than doing it by hand, believe me. The bigger the exponent, the more time you save. That's one of the kinds of questions I'm going to ask you. Actually, there's a different kind of a question I'm going to ask you. I may give you something like this. Don't write this down. And I may say, hey, find the 7th term, and only the 7th term. By the way, how many terms are there? 13. Okay. Or I could say, find the middle term, and only the middle term. If there's 13 terms, what would the middle term be? Term number what? 7. I wonder if there is a formula, as it were, that would let us just jump to a specific term. And there is. Turn the page. Here is the binomial expansion theorem. So for any number n, a plus b to the n is n choose 0, n choose 1, n choose 2. Stop when you get to n choose n. No b, 1b, b squared, stop when you get to b to the n. A to the n, 1 less, 1 less, 1 less. Stop when you run out of a's. What term number? What term number? Second. What term number? So let me see here. Term number 1 has what after the c? Term number 2 has what after the c? Term number 3 has what after the c? Term number k, isn't that term k plus 1? And that's going to give us our formula. Term k plus 1 is n choose k, a to the n minus k, b to the k. So what? This is on your formula sheet. It looks confusing. It's not. The reason it looks confusing is what we've said is because these are all going down by 1 and up by 1, somewhere we need to make an adjustment. Stay on this page, but look back here. I'll look back here. You see, when we expanded this, the first term had a 0 there. If I said find the first term, there's a 0 right there, and a 0 right there, and a 4 right there. That's a nice pattern, even though it's the first term. The third term has a 2 there, a 2 there, a 2 there. So what we said, you know what, let's, for our formula, since term 3 has a 2 there, and a 2 there, and a 2 there, term k plus 1, term 3 is going to have a 2 there, a 2 there, and a 2 there. Say what? Relax. I yoinked it right from here. It's on your formula sheet. It's much easier to do with an example. It says determine the fourth term in that expansion right there. Okay. I'm going to write down the formula. Term k plus 1, that's our abbreviation for term number. Term t with a little subscript of k plus 1 equals n choose k a to the n minus k b to the k. Okay? Shut up. Some of this you already know. We're going to make a list over here. Look at your question. What's sitting where the A is? This hasn't changed from 10 minutes ago. What's sitting where the A is? Carly. X. What's sitting where the B is, Carly? Carly, my angel, what term are they asking me to find? I'm going to write that like this. Term 4. Carly, what term? For me to get a 4 right here, what does K have to be? See it? That's the tweak we have to do. If I want to find the fourth term, I'm going to use K as 3. Oh, and what's N? This one's so obvious we forget. Go look at the pattern up here. What's N? Ellen, 9, the exponent. Yes? So in this hideous formula, Ryan, N is your exponent. K is, put the term number in there and subtract 1 to find K. N choose K. The rest is plug and chug. I'll show you. Ready? Ryan, in this question, what's N? 9. Choose. Ryan, in this question, what's K? What's A, Ryan? N minus K. In your head, what's the exponent going to be? N minus K. In your head, what's the exponent going to be? Yes, that easy. Keep going, Ryan. What's B? No, careful. Yep. K. Calculator now. Let's see, it's going to be 9, math, back arrow, choose 3, times -3 to the third. That looks like my number portion of this question, my coefficient of this question. Yes? Coefficient's going to be -2,268. What about my variables? X to the what? X to the 6th. That's the fourth term of that, and I didn't need to find the first 3 terms. Get out your formula sheet, please. Okay, so on the formula sheet under combinatorics and probability, it's this first row that we've done in this unit. There's the permutation equation. There's the combination equation. This is today. Tk plus 1 equals n choose k, a to the n minus k, b to the k. Example 3 says, write out the first 4 terms of the binomial expansion. I like this question, I like this question, I like this question, I like this question, I like this question. Write out the first 4 terms. I'm not going to use the individual equation formula that we just learned. I'm going to use the pattern. What? The pattern. Maria, what's my great big exponent on this question? What's n? Yep. So you ready? It's going to be 12 choose 0 space, 12 choose 1 space, 12 choose 2 space 12 choose 3. There's the first 4 terms, the start. Oh, Maria, a to the what? No, I'm not saying what is a, just in our pattern. A to the what? What was my big exponent? A to the 12th, then a to the what? 11th, then a to the what? Keep going. 10, then 9. And in the first term, Maria, this is a trick question, b to the what? No. There is no b in the first term. In the second term, b to the what? No. Because here's how you check. Maria, add your exponents. What do you get? Ah! B to the what? Add your exponents. What do you get? B to the what? Oh, and over here, technically b to the what? 0, which is why we didn't bother putting it. Okay? Yes, 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 yes. And how about, oh, let's write above the x that it's the a, and let's write above the positive 2y that it's the b. And I guess I should put plus signs in between everything so it just doesn't look like I barfed on the page. Here we go. Maria, what is 12 choose 0? And then it's going to be x to the 12th plus. Okay, what's 12 choose 1? Oh, that's 12, right? Right. X to the 11th, 2y to the 1. I'll tidy that up on the next line. Plus, I have no idea what 12 choose 2 is. 66. X to the 10th, 2y squared. Plus, I got no idea what 12 choose 3 is. 120? 220? X to the 9th, 2y cubed. All right, now let's tidy up each term individually. 1 times x to the 12th, I think that's just plain old x to the 12th plus 12 times x to the 11th times 2 times, okay, it's going to be, oh, 12 times 2, isn't it? Yes? A 24, and x to the 11th, and a y. Plus, it's going to be a 66 times a 2 squared. 66 times a 2 squared times a 4. 264. X to the 10th, y squared, plus a 220 times a 2 cubed. (1,760) x to the 9th, y cubed. You're going to see a question like that on your test. There's the first 4 terms of the 13 possible terms. Question, Eric? Good? A couple more. Can you turn in your workbook, please, to page 412. I think you're okay on the pattern. I want to practice finding a specific term a couple of more times. So page 412, here is that equation for finding a specific term. Term k plus 1 equals n choose k, a to the n minus k, b to the k. It's on your formula sheet. You don't have to memorize it. Turn the page, and let's try using it. Example 2a says, find the 5th term of a plus b to the 8th. Okay. First thing I'm going to do is I'm going to write down here at the top, term k plus 1 equals n choose k, a to the n minus k, b to the k. I'm copying out that formula verbatim from my formula sheet. And then I'm going to write down which term they actually want me to find. They want me to find term 5. Okay. If they want me to find term 5, Justin, if I want a 5 right there, really, what's the value for k? 4. The next thing that appears in this formula, Justin, is the letter n. What's n in this question? No. You guys are way overcomplicating it. What's n? 8. It's the exponent. It's the exponent. It's the exponent. It's the exponent. 8. By the way, Justin, we already used the 5 to figure out k. Why would we use it again? Oh, Justin, what's a in this question? Strangely enough, a. What's b in this question? Strangely enough, b. The 5th term is going to end up being... Okay, Justin, help me fill this in. What choose what? A to the B to the A to the 8 minus 4, B to the 4. Let's tidy this up. What does 8 choose 4? 70, A to the 4th, B to the 4th. That's the 5th term of that expansion. I didn't need to find out the previous 4 terms. B. The middle term. Oh, Tyler, what's my exponent? How many terms are there? Don't say 6. No. Huh? 7. What's the middle term? Term 4. All right. You still have this equation? You wrote this down at the top of the page? Yes, 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 yes. Okay. If I want term 4, Tyler, what's k? Yes. See. What's n? Don't overcomplicate it. Thank you. What's sitting where the a is, Tyler? What's sitting where the b is? Don't say 5. Negative 5. Now it's plug and chug-ish. It's going to be, Tyler, what choose what? 6, choose 3. What to the what? 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 2a to the what? 3? What? To the what? Now, in both of these 2 numbers have been the same. That's just a fluke. It won't always be the same. Okay. In terms of numbers, coefficients, Tyler, it looks like it's going to be 6, choose 3, times, can you see, Tyler, a 2 to the 3rd? See it? And then times, in brackets, a negative 5 to the 3rd. See it? You know what my coefficient's going to be? Ta-da! Negative 20,000. Negative. What are my variables going to be? A cubed. Oh, just it. That's it, isn't it? A cubed. Okay. We've got about 3/4 of the lesson done. We're going to pause here, but here are some questions that you can now do on this page. You can do number 4. 7, including C, D, and E. Oh, heck. And 8. Okay. Oh, one more. 12. I also have a take-home quiz for you. Take-home quiz number 2.